Hello, beautiful algebra students. Welcome to another episode of Mr. Chow Time. We're still on Unit 1, Expressions and Equations, but now we're on Lesson 4, the Distributive Property. If you're following along in the book, this is on page 23. So, what is the distributive property? Well, pretty simple. If you have a number like A that's being multiplied by a grouping of two things that are added or subtracted, then you can just distribute the number. So for example, if you have 3 times 2 plus 5, you can distribute the 3 to the 2 to get a 6. You can distribute the 3 to the 5 to get a 15. And you'll get 21. That's one way to do it. Or you can just, add what's on the inside and multiply what's on the outside. So, as you can see, both ways, you get to 21. The symmetric property of equality allows the distributive property to be written as follows. So remember the symmetric property, that's basically like A equals B is the same thing as B equals A. So, if A times B plus C is equal to AB plus AC, then AB plus AC must equal A times B plus C. For example, let's do an example together. A group of 5 students and 4 parents are going to KAS game night. Use the distributive property to write and evaluate an expression for the total ticket cost. So, how do we know what the total ticket cost is going to be? Well, we know that there's going to be 5 students, right? And the cost for students is $5. We know there's going to be 4 parents. Cost for parents is $3. And groups of 10 or more are $2. Oh, well then let's just change this. Haha, let's change that to 6. So now we have a group of 10 or more, right? So let's just do this thing here. So we have 2 times 5 plus 6, right? And so 2 times 5 is 10, plus 2 times 6 is 12, and that's 22. It's going to cost $22 for the tickets. Riveting. Let's do another example. Why do we do the distributive property? Well, another nice thing we can do is mental math. So instead of multiplying 6 by 49, for example, you can multiply 6 by 50 minus 1, because these are much easier numbers to deal with, right? So 6 times 50, well, that's 300. 6 times 1 is 6. So the answer is 294. Is that right? Someone use a calculator. Check me. I'm often wrong on these things, and I don't have any students here to tell me when I'm doing something wrong. The distributive property can also be used to rewrite expressions. So here we just have an expression with a grouping, and then it's being multiplied by -5. So we can just distribute this -5 to all of these terms inside of this grouping. -5 times 2x squared is -10x squared. -5 times -3x is going to be a positive 15x. And then -5 times a positive 4 is going to be a -20. We've done it. We've rewritten the expression. And there's no more parentheses, which means it's simplified. Next, like terms. Like terms are terms that contain the same variable with corresponding variables having the same power. So in an expression, there will be terms. Those are the numbers or variables, or numbers or variables with coefficients. that, you know, are between operations. Did that make sense? I'm losing it here. Okay, so 4x plus 2x plus 3y. These two are like terms because they have the same variable and the same power, right? So these are both to the power of 1, basically. So this can be rewritten as 6x plus 3y. These are like terms, these two terms here. Simplest form is an expression that contains no like terms, or parentheses. So 5 times 2x plus 3y. Well, this has parentheses, right? So 10x plus 15y. This is now simplified because x and y are not the same variable, so you cannot combine these like terms. Yay! So let's simplify this expression. Excuse me, did I just move the screen a little bit? My bad, my bad. Oh my goodness. What am I doing here? I can do this, I can do this. You like that? Alright. Simplify the expression. 12c squared. C squared. So we have a c. We have another c here and another c here. But as you can see, this one has a power. And that's squared, right? The exponent here is 2. So that means this is not like terms with these. But these two are like terms. Yay. So 12c squared, positive 4c, negative 2c. We combine those for a positive 2c. And then here we have 2x. 2x, there's no other x's, so we'll just keep the 2x. And then we have plus 2 plus 2. We have two numerals here. Those are like terms. They're just numbers. 2 plus 2 is 4. So now we have no more like terms. And that's how we simplify that expression. We can also write expressions just as a reminder from verbal expressions, right? Twice the difference of 3x and y. Difference of 3x and y increased by 5 times the sum of x and 2y. Did everyone follow that? How did I get to that? Twice the difference. I know that this is a grouping because we're talking about the difference of 3x and y. And it doesn't say like 2 times 3x minus y. You know, it's not like, how do I say this? It's not like 2 times 3x less than y or something like that. This would just be 2 times 3x minus y. But we're not doing this. It's twice the difference. So the difference here is grouping this here. Increased by 5 times the sum. The sum is grouping these things together. Okay, so 2 times 3 is 6x minus 2y plus 5x plus 10y. And then we have some like terms here, right? So we need to simplify that. 6x and 5x, that's 11x. Negative 2y and positive 10y, that's going to be positive 8y. And now we've done it. We cannot simplify that anymore. Next, coefficient. Coefficient is the numerical value of a term. So when we have a x plus y, these coefficients have, these terms, these variables have a coefficient of 1, right? 2x plus 2y, that looks kind of like a z. 2 is the coefficient. It's the number that goes along with the variable. Let's look at our last example. Oh my goodness. Okay. Oh no, this is not an example. This is just a concept summary. Commutative property, associative property, identity property, zero property, distributive property, substitution. I'm just going to let you read this instead of rereading it all again. Thank you. See you in class.